Guys, welcome back to day 3 of online learning. Today we're going over 6.4 and this entire section is on rectangles. So yesterday we were talking a lot about parallelograms and quadrilaterals. And now we're going to recognize and apply properties of rectangles and then determine whether parallelograms are rectangles. So some new vocabulary here is a rectangle. You guys know what the shape is, but we're going to talk a lot more about the properties and the definitions. So the definition is a parallelogram with 4 right angles. So remember, everything that we learned yesterday about parallelograms is going to be true about a rectangle because a rectangle is a parallelogram. So here's a theorem. It's talking about the diagonals of a rectangle. So it's telling us if a parallelogram is a rectangle, so that's what's given, then its diagonals are congruent. So here they give us this parallelogram JKLM, and they're telling us that it is a parallelogram. So knowing that information, we can prove that the diagonals are congruent. So we're going to apply that a little bit. Okay, so here's a garden gate, all right, and we have these diagonal braces to keep it in its correct shape. And so it's telling us that JK is 12 feet, so I'm just going to mark that in. We have 12 here, okay, and then LN is 6.5 feet, so here's 6.5. All right, we have to find KM, so this whole diagonal, what is that? Okay, so going back to what we know about parallelograms, their diagonals bisect each other. So if we know that JN is 6.5, we could also say that NL is 6.5. Okay, there's supposed to be a point in there. Okay, so now if we add those two together to find out what JL is, we're going to get 13. But we're not looking for JL, we're looking for KM. But we were just told that if a parallelogram is a rectangle, then it has congruent diagonals. So if JL and KM are diagonals, and one of them is 13, they'll both be 13. So we find that KM is 13. And this is going to go into it a little more in detail, but doing the same things that they did. They found what that JL was using that 6.5 that they gave us. And then we can say that they're congruent, so we get KM is 13. Okay, here's one for you guys to try. Go ahead, pause your video, do a little working out. Okay, we're given that GH is 6 feet, and honestly that's not really important because we're looking at the diagonals, right? So it tells us that FH is 15, so this entire diagonal is 15. Well, if this is a rectangle, our other diagonal will also be 15, and if we're looking for GJ, we know that's going to be half. So we get 7.5 because that's half of that diagonal. Okay, next example, a little more algebra. We have some variables in here. And now we're talking about angles. Okay, so it gives us the measure of angle RTU. So RTU is right here. All right, and we have 8x plus 4. All right, then it also gives us angle SUR. Oops. Sorry, this isn't right here. This is over here. RTU is right there. That's our 8x plus 4. Okay. And then it also gives us SUR, which is right here. And they tell us that that's 3x minus 2. Okay, notice that these angles that they give us aren't next to each other, so we have no idea what to do with them. But there's something important to remember. If these diagonals are congruent and they bisect each other, then this PT will be congruent to PU, which then makes that an isosceles triangle. So this angle will be congruent to this angle. Okay? So this little part right here is also this 8x plus 4. Now maybe you're seeing something that we could be doing. Rectangles have right angles. So if we have this 3x minus 2 and this 8x plus 4, if we add those together and then set them equal to 90 because it's a right angle, then we can find what x is. So let's do that. we have 3x minus 2 plus 8x plus 4. Oops, running into our diagram here. That equals 90. Okay, so let's combine our like terms here. We get 11x plus 2 equals 90. Alright, subtract that 2 over, we get 8. 11x equals 88. X equals 8. Okay, so we just combined our like terms to get to this stage, subtracted that 2 over, then divided by 11, so we got x equals 8, which is exactly what it was asking us to do, was finding x. And there's a long description of what's going on. They're doing the same steps that we did. Boom, they got x equals 8. Okay? Now here's one for you guys to try. Go ahead, pause your video, work this out on a little side piece of paper. Okay, so this is the same type of deal where they're giving us two angles that aren't necessarily next to each other, but we can figure out what to do with them using some properties. So here they give us the measure of angle FGE, which is right there, okay? And then they also give us the measure of angle HFE, which is right here, okay? Now knowing that this is a parallelogram and a rectangle, right, we can say that this GJ is congruent to JF, which then makes that an isosceles triangle. So this little angle is going to be congruent to that little angle. So again, we can take this expression that they gave us for this angle plus that expression, set it equal to 90. So let's do that quick. So we have 6x minus 5 plus 4x minus 5. And remember, we're setting that equal to 90 because it's a right angle. Okay, so our next step, we're combining like terms. So we get 10x minus 10, still equal to 90. Okay, we're solving for x, got to get that by itself. Add 10 to both sides, so we get 10x equals 100. Divide by 10, we get x equals 10. Let's check our work. There we go. Okay, let's move on to the next example. So now we're talking about if we're given that the diagonals of a parallelogram are congruent. That's what our hypothesis is. Now notice that there's two different things in there. It's telling us that the diagonals are congruent, but it's also saying it's the diagonals of a parallelogram. So in order for this to work, we have to know that what the shape that we're given is a parallelogram. Okay? And if we can prove that, then it's a rectangle. So let's apply that now. Okay, so this is a really long word problem, but it just has some extra information about the diagram. So we're given these wooden frames and we're putting canvases over them. Okay, let's just look at this information, the stuff with the numbers. So we're going to go ahead and plug some things in. So it says AB is 12 inches, so we have 12 here. Okay, BC is 35. Where's BC? It's this side. 35. CD is 12, so we have 12 over here. DA is 35. Here's 35. Okay, it says AC is 37. So AC, this diagonal, I'll just say is 37. Okay, given this information, our opposite sides are congruent and they look parallel, so we can say that it's a parallelogram. Okay? Oh wait, it also tells us that BD is 37, so we have 37 here. Okay. So we prove that it's a parallelogram. Now, it also tells us that our diagonals are congruent, they're both 37. So using that theorem that we just talked about, this shape is a rectangle. Okay, and this page is just kind of talking about that same thing. We prove that the opposite sides are congruent, the diagonals are congruent, boom, rectangle. Okay, here's another one for you guys to try. It's a little bit different, okay? So now we're talking about a swimming pool. We're measuring the length and width of the pool so that the opposite sides are parallel, okay? The opposite sides are parallel, so now we know it's a parallelogram. He also measures the diagonals of the pool to make sure that they are congruent. How does he know that the measure of each corner is 90? In other words, how does he know that this pool is going to be a perfect rectangle? All right, so we know the opposite sides are parallel. Got to know more than that. The opposite sides are congruent. Got to know that. Since the diagonals of the parallelogram are congruent, then it must be a rectangle, or it's not a rectangle. We're going to go with option C here, because we know that the diagonals of the parallelogram are congruent, and that's that theorem that we were just using. We need to know that it's a parallelogram, but then we also need to know that the diagonals are congruent as well. Okay. So now we're given some vertices, okay? Notice any time that we use vertices, or we're given vertices, we have a couple different tools that we can use. This one is hinting that we're going to use the distance formula, but if it didn't hint that, remember we have the distance formula, we know how to find the slope using the slope formula. Sometimes we have to find the midpoint using that midpoint formula, so we're going to really pull from that toolbox if we're given vertices. Okay, so we're given a quadrilateral, and it gives us the vertices of all of the points. We have to determine whether JKLM is a rectangle using the distance formula. So first what we have to do is we have to prove that this figure that they're giving the vertices of is a parallelogram. So to do that, we're going to find the distance between all these points to find the side lengths. Okay? So here's the sketch of our diagram. Okay, the next page, we're finding all these side lengths, okay? JK and ML, those are opposite sides, and they both have a length of √10, so they're congruent. Okay, KL and JM are also opposite sides, and we get √40 for their length. So now we know that the opposite sides are congruent, so it must be a parallelogram. Okay, but we still have to prove that it's a rectangle. So that's where we find the diagonals. Okay, that's what I just talked about. Now we're finding the diagonals. So we're taking the 2 points that are on opposite ends, and we find that they're congruent. So this figure that they gave us the vertices of is a rectangle, because we proved it's a parallelogram, and we proved that the diagonals are congruent. Okay, here's one for you guys to try. I encourage you on a side piece of paper, sketch this out, do a little bit of the distance formula. Okay, so we're given vertices for W, X, Y, and Z. Now, if we were just to sketch it out, I'm just going to pretend it's a perfect rectangle, if I could draw a perfect rectangle. Okay, so we have W, X, Y, Z. So we would need to find WX and YZ to be congruent. Then we would find XY and WZ to be congruent. Okay, and that's just proving that it's a parallelogram. Now if we go in and find WY and XZ, and if we found those to be congruent, which we will, then it's a rectangle. Okay? Oops, it's a parallelogram. Okay, this page, got a little ahead of myself, sorry guys. This page, now we're finding the distance between those opposite endpoints to find the length of the diagonals. So when you plug that into the distance formula, we'll get 5. Okay? So really short lesson today, make up for yesterday's 2 lessons. So today we're doing page 426, 11 through 43 odd. You can skip 21 and 33. As always, let me or Mr. Knutson know if you have any questions on the material. Use your other resources if you have a small question and you don't want to ask us. Good luck on this, guys.